Right now, tiny dust from deserts far, far away might be secretly changing our whole climate, likely making it way cooler. Scientists have found that strong winds carry those particles and they can travel thousands of miles through the air. Eventually, they end up in the sky, inside clouds. And once they're there, they start to change the way clouds behave. Try to think of clouds like giant mirrors in the sky. They reflect sunlight back into space and help control how much heat stays on Earth. But when you add dust into the mix, everything gets messed up. The particles act like tiny triggers that make water droplets freeze into ice, even when the temperature is only slightly below freezing. It might sound harmless, but it's not. When clouds freeze, they begin reflecting sunlight differently, and they also change how rain and snow form. So something as small as dust can affect how much heat the planet keeps and how much it loses. A team of researchers from ETH Zurich used 35 years of satellite data to figure out this phenomenon, and they found a clear pattern. When there was more dust in the air, clouds were much more likely to freeze at the top, especially mixed-phase clouds. Those are clouds that contain both liquid water and ice at the same time. They form at temperatures between about 32 degrees Fahrenheit and negative 38 degrees Fahrenheit. They're super common across the northern hemisphere, especially over places like the North Atlantic, Siberia, and Canada. These clouds are very sensitive. It doesn't really take much to push them from mostly liquid to mostly ice. All you need is just a bit of desert dust. Well, it's just one of the factors, but an important one. Scientists have been studying how tiny water droplets freeze for years, usually in labs. They examine things so small you need powerful microscopes to even see them. We're talking about structures measured in nanometers. That's about 0.000004 inches. And now we observe the same behavior, but on a massive scale. Those tiny dust particles are affecting clouds that stretch for miles across the sky, big enough to be seen from satellites orbiting Earth. When scientists started looking at dust levels and what clouds were doing, they spotted a clear pattern. More dust plus colder air resulted in more ice forming in the clouds. But the most worrying thing is that it's not just happening in one place. This is going on across huge areas, and it's really hard to predict how it will affect the climate. What we know is that frozen clouds drop rain and snow way more heavily than usual. So storms can get stronger and snowfall can get way more intense across huge parts of the northern hemisphere, from regular climates all the way up to polar regions. So basically, these tiny invisible dust particles floating in the air could be setting things up for massive, unusual storms. And we don't fully understand this process yet. I mean, how do you even track how much dust is flying out of deserts every single day? Scientists say that if this keeps happening, things could get really extreme. Storms, heavy snow, and weird weather could start happening more often, and no one will be able to predict where or when. But it's not the same everywhere. In places like the Sahara Desert, for example, there aren't many clouds to begin with. That's why the hot, rising air can actually make freezing less likely. In the southern hemisphere, things work differently too. There, sea salt and particles from the ocean might play a bigger role than desert dust. So the picture isn't that simple. Scientists still need to figure out how other factors come into play, like how fast air moves upward or how much moisture is in the air. All of these things can change how clouds freeze. But if you're worried that dust will make our planet colder, you should probably know that, technically, we're still living in an ice age. You see, this ice age started about 2.6 million years ago. It's called the Quaternary Glaciation, or the Pleistocene Ice Age. Right now, we're in a warmer break inside it, which is called an interglacial period. But about 650,000 years ago, the world looked very different. Huge animals like mammoths and mastodons roamed across North America, and not far from them was something even more massive, a gigantic sheet of ice, in some places almost 2 miles thick. That's taller than most mountains you can see today. This ice covered most of what we now call Canada and stretched down into parts of the United States. Then the planet warmed up. The ice slowly pulled back, and places that were once buried under ice, like modern-day Quebec or Chicago, became livable. but the ice didn't go away completely. Even today, massive ice sheets still sit on top of Greenland and Antarctica, and they hold an unbelievable amount of water. If all that ice melted, sea levels could rise by hundreds of feet. Entire cities would disappear underwater, and in recent decades, these ice sheets have started melting faster. Are we heading toward a world with no ice at all? The real end of the Ice Age? Most scientists don't think everything will melt anytime soon, not within this century, but even a tiny change could still be a huge problem. Some estimates suggest sea levels could rise by up to 3 feet. Doesn't sound like much, right? But even 1 or 2 feet is enough to flood coastal areas and force millions of people to leave their homes and move inland. And that's why scientists are trying to get more precise answers. Now, speaking of ice ages, there's some sort of connection between them and that pesky dust that seems to be cooling our planet. You see, there are glacial periods when things get really cold. They can last tens of thousands of years, and huge ice sheets spread across large parts of the planet. Then, there are interglacial periods, like the one we're in now. These are warmer breaks that usually last only a few thousand years. The climate during these times feels a lot like what we have today. But what causes these big shifts? Scientists are still trying to figure it out, but one of the main factors is simple: sunlight. It all depends on how much sunlight Earth gets, and that changes over time because of several things. First, the tilt of our planet. Sometimes it leans more, sometimes less. Second, the wobble. Earth doesn't spin perfectly straight, it wobbles a bit, like a spinning top. Third, the shape of Earth's path around the sun. Sometimes it's closer to a circle, and sometimes it stretches into more of an oval shape. And finally, it might be how much sunlight the clouds over our planet reflect. That's where the desert dust comes into play. Over thousands of years, these small changes add up. They can change how much sunlight reaches certain parts of the planet, especially the northern regions near the North Pole. When less sunlight reaches those areas, temperatures drop, more water freezes, and ice sheets start growing. That's how an ice age begins. When more sunlight reaches the same regions, the opposite happens. Temperatures rise, ice melts, and the planet moves to a warmer phase. But it's not just sunlight. There are other factors too, and scientists are still piecing them all together. To understand what happened in the past, researchers study ice cores. Those are long cylinders of ice drilled out of glaciers. Layer by layer, they store information about Earth's climate going back hundreds of thousands of years. What they show is pretty exciting. During this current ice age, Earth has switched back and forth between cold and warm periods at least 17 times. And it's very likely that the planet will turn cold again someday, maybe already in a few thousand years. But now there's a new factor in the mix: humans. Our activity makes it harder to predict the next ice age.
Nearly 12,900 years ago. Hey, I wasn't around then. But something happened that pushed the northern hemisphere back toward the Ice Age. For years, scientists thought the cause was a huge asteroid. But new research points to something that was here on Earth all along. A volcano hidden beneath ice or underwater that, instead of melting the ice, did the opposite and made Greenland even colder. Scientists call this abrupt deep freeze the Younger Dryas. Despite how it feels with those unbearable summer heat waves around the world, Earth is still technically in an ice age. Earth's orbit and axis go through all kinds of tilting and wobbling, which is why we swing between colder glacial and warmer interglacial periods. Right now, we're in an interglacial period, named the Holocene. But before civilizations could really grow crops and enjoy summer, they had to endure this unexpected freeze that lasted for about 1,300 years. Evidence from Greenland suggests this change happened within just a few decades. Temperatures dropped by more than 27 degrees Fahrenheit, winds got stronger, and the entire North Atlantic started acting like someone turned the freezer up a few notches. In Europe's sediments, the plant record flipped back to cold climate tundra. That shift even brought back a tough little Arctic flower, Dryas, in the middle of Europe. And that's what this sudden, teeth-chattering cold spell was named after. But why the unexpected brrr? The clue comes from deep inside the Greenland ice sheet. All that endless ice is like the Earth's hard drive, with all the events sorted in order. When it snows in Greenland, the snow doesn't really melt away. Instead, more snow just keeps piling up on top of it each year. Over time, all that weight squashes the layers beneath, turning them into ice. This process captures tiny air bubbles that hold bits of the atmosphere. Basically, the frost keeps a snapshot of whatever was happening in the sky at that time. For example, if there was a big forest fire in Canada 5,000 years ago, the smoke and soot would drift over to Greenland and settle on the snow. If a big asteroid impact really happened around then, you'd expect its chemical traces to show up in the ice layers from that time. Now, to access this data, scientists use massive hollow drills. They drill deep into the ice and pull up long cylinders called ice cores. And because Greenland's ice is nearly 2 miles thick, those cores can preserve a ridiculously long climate record, allowing scientists to examine ice that's over 100,000 years old. By examining ice cores from that period, researchers found a sudden spike in platinum. This element is super rare near Earth's surface, but it's much more common in meteorites and asteroids. That's why theories were pointing to something huge from space. But how could an asteroid cause climate change? Well, basically, it works like this. Let's say a giant rock slams into an ice sheet. The impact blasts dust, ash, and all kinds of particles high into the sky, way above the clouds. Big booms can cause massive fires, adding even more smoke. Now the planet is wrapped in a dusty, smoky layer that blocks part of the sun's energy. The thing with ice is, when it doesn't melt, it spreads and reflects sunlight back into space, which makes things colder again. That loop is called the ice albedo feedback. Sounds like a cool theory for the younger Dryas. And just to make it even more tempting, Greenland also seems like it might be hiding the actual crater. Radar surveys beneath the Hiawatha Glacier revealed a round structure about 19 miles wide. Scientists were wondering if this was the one that caused the younger Dryas, but dating showed it was about 58 million years too old to be the culprit. Also, a platinum spike doesn't automatically mean a meteor. Platinum from space usually comes with a supporting buddy metal called iridium. If you find one, you should find the other. But when scientists analyzed the Greenland ice, iridium was missing. So the chemistry didn't really point to a meteor. It looked more like volcanic magma from the North Atlantic. Then there's the shape of the platinum signal. It drains on for multiple years, not one sharp boom layer. That's more like something steadily feeding the atmosphere, not one big explosive impact. So, if platinum isn't pointing to a fresh impact, the next question is simple. What on Earth can put platinum into the sky and also cool the planet? The answer is a volcano. The kind they're talking about could have been in the North Atlantic region, possibly in Iceland, and it may not have even been fully on land. It could have erupted under thick ice, or underwater. Here's the difference. When a volcano blows its top in the open air, we get ash clouds and oozing lava rivers. But under the ice, magma hits meltwater, flashes it into steam, and can explode into fine ash and gas. Underwater, powerful eruptions can also fragment magma and push material upward. In both cases, the real trouble isn't the molten rock, it's the gas. Hey, I can relate. Now, big eruptions like these spit out massive amounts of sulfur dioxide. If that gas gets high enough, like miles above the clouds, it spreads out and mixes with water vapor to create sulfate aerosols. These are basically microscopic droplets of sulfuric acid. Individually, they're invisible, but get billions of them floating together and they act like a planetary shade. From space, Earth actually looks shinier because those droplets are reflecting sunlight. But down here on the ground, it's like looking at the sun through a thin, silvery veil. You don't need total darkness to freeze the world, you just need to dim the sun a little. Summers stop being truly warm, and snow survives into July. That leftover snow compacts into ice, which reflects even more sunlight. It's the same kind of feedback loop as the one triggered by an asteroid, except in that case, the sun is blocked by dust, while here, it's reflected back into space. Something similar happened quite recently. In 1991, Mount Pinatubo in the Philippines unloaded about 20 million tons of sulfur dioxide into the stratosphere. It wrapped Earth in a thin veil, and global temperatures dipped by about 1 degree Fahrenheit for about 2 years. Just imagine the scale of the eruption if Greenland's temperatures had dropped by more than 27 degrees Fahrenheit and stayed that cold for 1,200 years. But here's an interesting question. Could it be neither? Not a climate-changing asteroid, nor a hidden volcano. There's a third suspect that's much quieter, but just as dangerous: fresh water. One leading theory is that the world warmed up and a massive glacial lake in North America, often linked to Lake Agassiz, suddenly drained or rerouted, dumping an absurd amount, like quadrillions of gallons, of fresh water into the North Atlantic system. That fresh water diluted the surface ocean in regions where dense, salty water normally sinks and helps drive large-scale Atlantic circulation. When that sinking weakens, the overall circulation slows down and less ocean heat reaches the North Atlantic. With that system disrupted, the Northern Hemisphere could cool extremely fast on a climate timescale, within years to decades rather than centuries. In that version, the platinum spike could be a coincidence, a volcanic burp during the freeze, not the trigger. And in the end, if the volcano was the cause of the endless winter, could this happen again in our time? Absolutely. The North Atlantic region is still geologically active. Iceland erupts regularly, and the volcanic systems along the mid-Atlantic ridge are very much alive. But it wouldn't be a jump scare out of nowhere. Even volcanoes buried under the ice usually give warnings, like earthquakes. If heat builds down there, it can melt large volumes of ice from below before anyone sees ash in the sky. On the other hand, it wouldn't need to be a planet-destroying eruption. A moderate blast that injects sulfur high into the stratosphere could dim sunlight for a couple of years, just like Pinatubo did. That does not mean a new ice age will start the day after. Today's climate background is very different from 12,800 years ago. But the mechanism is real. The atmosphere can still be nudged, and sometimes all it takes is a hidden eruption.
Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, Melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The US East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the US East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100.
Hey, want to take a wild trip back in time to the Jurassic or Cambrian era? Trust me, it's going to be a wild ride, but surviving in those ancient environments would require some serious skills. At the start of the Cambrian era, the air would be as thin as at the base camp of Mount Everest, but the climate was actually pretty chill and consistent back then. However, there was one teeny tiny problem: no land plants or animals to feast on. So forget about firing up the grill for a juicy steak. Instead, you'd have to come up with creative ways to catch trilobites and other funky-looking shellfish. Good luck finding a spear without any wood or a fishing net without any plant fibers. And get ready to eat them raw, unless you can figure out how to extract oil from these creatures or burn dry seaweed. But wait, if you're looking for a more comfortable existence, you gotta travel to 100 million years ago, to the Silurian period. Here, things start to get a bit easier. The air is still thin, but there's a bit more oxygen to go around. Plus, the climate is warmer and cozier. Simple land plants have finally made their debut. Not only that, but the first bony fish also show up on the scene, so you might actually find something more palatable to munch on. Just watch out for those prehistoric millipedes and spider-like creatures that share the land with you. They might not be the best dinner companions. Yeah, it all sounds fun and feasible, but let's talk a bit more about this crazy idea of instant transportation. If you magically appeared in a different time, the first thing you'd have to worry about is the amount of oxygen in the air. Now, looking at that fancy graph up there, it's pretty clear that oxygen levels used to be super low before about 0.85 billion years ago. Like, we're talking just a few % of the atmosphere. And there wasn't even any O2 in the air until this event called the Great Oxygenation happened about 2.3 billion years ago. So if you ended up back then, surviving would totally depend on how fit you are. If the oxygen concentration was less than 10%, you'd probably pass out, but not pass away. If it was just above 10%, you might be able to function, but you wouldn't exactly be living your best life. Based on oxygen alone, it seems like you could survive if you showed up around 0.75 billion years ago, give or take a few million years. Now let's talk about the cool stuff on land. The first land plants didn't show up until around 450 million years ago during the Ordovician period. Before that, there were some large algae hanging around, mostly in the range of 500 to 600 million years ago. But there wasn't a whole lot going on until those land plants came along. Other forms of life didn't start showing up on land until closer to 300 to 400 million years ago. But there was this critter, a myriapod, that lived around 428 million years ago, and it was one of the earliest land dwellers. I mean, if you lived back then, you'd have to come up with fancy recipes featuring myriapods. Not exactly mouth-watering. Don't worry if you find yourself back in time before all that land action. Around 500 to 600 million years ago, the oceans were teeming with life. There were these creatures called the Ediacaran fauna, and they were some of the first well-preserved organisms. Some of them probably hung out in the shallow areas near the shore, so you might be able to get your hands on them for a meal. But remember, there weren't any land plants yet, so you'd probably have to eat them raw and with no potatoes on the side. You'd have a sort of prehistoric sashimi on your plate. Now, around 500 million years ago, things started to get really interesting in the oceans after something called the Cambrian explosion. If you ended up in the Cambrian period, you'd have all sorts of weird animals to catch in the coastal zones. Check out the fossils from the Burgess Shale for some wild ideas. Look at these brachiopods, arthropods, and even worm-like critters. But again, no woody land plants at this point, so your meals would mostly consist of raw arthropods and algae. Alrighty, let's dive into the nitty-gritty of ice ages. It's when the Earth gets super chilly for a ridiculously long time, like millions and millions of years. This causes giant ice sheets and glaciers to spread all over the place, covering massive areas of the planet's surface. Believe it or not, our planet has experienced at least 5 major ice ages. The very first one happened about 2 billion years ago and lasted for 300 million years. The most recent ice age kicked off at around 2.6 million years ago, and we're technically still in it. So, we're in the middle of an ice age, but we're not currently living in an icy wonderland. That's because we're currently in an interglacial period. During an ice age, temperatures go through ups and downs. When it's warmer, those ice sheets and glaciers start to melt, creating what we call interglacials. And when it gets colder, they expand again, which we call glacials. So right now, we're enjoying the warm interglacial period of the most recent ice age, which kicked off around 11,000 years ago. When people mention the Ice Age, they're usually talking about the last glacial period that started around 115,000 years ago and ended roughly 11,000 years ago when our current interglacial period began. During that glacial period, things were way cooler than they are now. At its peak, when ice sheets covered most of North America, the average global temperature was about 46 degrees Fahrenheit. That's a whole 11 degrees Fahrenheit cooler than today's global average temperature. That temperature difference may not seem like much, but it was enough to turn most of North America and Eurasia into ice-covered landscapes. The Earth was also a lot drier, and sea levels were way lower because most of the water was trapped in those ice sheets. We're talking vast steppes, dry, grassy plains as far as the eye can see. And let's not forget about the savannas, warm, grassy plains, and deserts that were also part of the icy scene. During the Ice Age, there were some familiar critters roaming around, like brown bears, caribou, and wolves. But there were also some mega cool creatures that sadly went extinct when the Ice Age came to an end. We're talking mammoths, mastodons, saber-toothed cats, and giant ground sloths. Now, there are a bunch of theories floating around about why these magnificent beasts bit the dust. One idea is that us humans hunted them into extinction when we crossed paths with these megafauna. Our species, Homo sapiens, actually survived the Ice Age. We've been kicking it on this planet for around 300,000 years now, starting out in Africa and then spreading our awesomeness all over the globe. Some of our ancestors stayed put in Africa and didn't experience the full icy effects. Others ventured into different parts of the world, even braving the freezing cold of Europe's glacial environments. But we weren't the only ones out there. At the beginning of the Ice Age, there were other hominids, our closer relatives, scattered across Eurasia. We had the Neanderthals chilling in Europe, and the mysterious Denisovans hanging out in Asia. Sadly, both of these groups seems to have vanished before the Ice Age wrapped up. Now, there are countless theories about how our species managed to survive the Ice Age while our hominin buddies didn't make it. Some believe it's because we're ridiculously adaptable and used our social skills, communication, and nifty tools to our advantage. And get this, humans didn't just hunker down during the Ice Age. Nope, we explored new territories and made ourselves at home. For the longest time, folks thought humans didn't set foot in North America until after the ice sheets started melting. Fossilized footprints discovered at White Sands National Park in New Mexico prove that humans have been rocking it in North America for at least 23,000 years, right around the peak of the last Ice Age.
Did you know that the Pleistocene era was a really important time in Earth's history? It's when the last Ice Age happened, and glaciers covered a lot of the planet. This period of time lasted for about 2.6 million years, and ended around 11,700 years ago. What's even cooler is that modern humans, like us, had actually evolved during this time, and had spread all over Earth before it ended. There were also some really fascinating animals that lived during the Pleistocene, like woolly mammoths and saber-toothed cats. Unfortunately, many of them went extinct at the end of this era. Earth has had some pretty wild weather patterns over the last 2.4 billion years. Although the planet is mostly ice-free, we now cycle in and out of freezing ice ages. During these glacial periods, temperatures drop and huge areas of the planet get covered in ice. It all starts with a bit of snow, which then builds up over time. The ice reflects sunlight, making things even cooler. The result? Vast glaciers that slowly move toward the equator, changing the landscape as they go. And when the ice melts, sea levels rise again, and everything changes all over again. In total, there have been at least 5 ice ages so far. The first one was so intense that the whole planet turned into a huge snowball. Right now, we're actually in the middle of an ice age, but we're currently in a temporary warm spell that started around 11,000 years ago. These warm periods are called interglacials, and we're not quite sure how long they last. There are still massive ice sheets covering Antarctica and Greenland that hold 75% of Earth's fresh water. When these finally melt, it'll mark the end of the current ice age. Earth's temperature is affected by something called the Milankovitch cycles. Basically, the amount of heat we receive from the sun changes over years, decades, and millennia because of Earth's orbit, tilt, and axis angle. There are 3 different patterns to these cycles. The first is called eccentricity, which is all about the shape of our orbit. The second is obliquity, which has to do with the tilt of the Earth. And the third is precession, which is like a wobble as Earth spins. Depending on where we are in these cycles, we might experience colder or warmer temperatures. But other things, like the position of continents and the atmosphere, also play a role in our planet's fate. For example, our planet's orbit is not quite circular. It's actually a bit elongated, shaped almost like an egg. That means we're sometimes a little closer or farther from the sun, depending on the time of year. We call the point farthest away from the sun the apogee, and the closest point is the perigee. When we're at the apogee, we're moving away from the sun, but gravity eventually pulls us back toward it. This means our orbit changes a little each time, gradually shifting our position relative to the sun. Don't worry, even though the orbit changes over thousands of years, it doesn't have a big impact on our day-to-day lives. Changes in Earth's orbit can affect how much sunlight we get during the summer. This means that ice sheets in the northern hemisphere will melt less, and over time, they actually start to grow. As they grow, they reflect even more sunlight, which makes the climate even cooler and spreads the ice even farther. This process can last for a really long time, like 10,000 to 20,000 years, and eventually it brings the planet into its next freezing season. As for the next ice age, scientists believe it might be postponed indefinitely. They've found that our human interaction with the environment, like the use of fuels, could delay the next ice age by up to 100,000 years. Earth's past ice ages were linked to the amount of solar radiation and carbon dioxide concentration in the atmosphere, and this research can even help us predict future cycles. It's amazing to think that our actions now could affect Earth's future for thousands of years to come. And while it's not really important when the next ice age begins, it's pretty cool to know that humans have the power to shape the future on a geological timescale. Ice ages have had a huge impact on our planet and human civilization. So it's fascinating to think how our actions now might change things, maybe even for the better. What did life look like on our planet during the last ice age, though? Well, North America, for instance, was home to some huge creatures. Mammoths, saber-toothed cats, giant ground sloths, and mastodons were just a few of them. And get this, even Europe had an 11-foot tall flightless bird that weighed almost as much as a polar bear. Meanwhile, down under in Australia, there was a giant lizard that lived in all sorts of habitats during the same time period. Even though some animals from the Pleistocene era aren't around anymore, you might recognize many of those that are still around today. In Alaska, for example, you can still find brown bears, caribou, and wolves. People just like us actually lived through the Ice Age too. Our species, Homo sapiens, has been around for about 300,000 years. And we've spread all around the world since then. Some of our ancestors stayed in Africa during the Ice Age and didn't feel the full effects of the cold. And others ventured out into other parts of the world, even into the chilly glacial environments of Europe. Our early relatives, like the Neanderthals in Europe, and the mysterious Denisovians in Asia, were also around during this time. Although they seem to have gone extinct before the end of the Ice Age, it's pretty amazing to think about all those different hominids that roamed Earth during that period. What's also fascinating is how our species managed to survive the Ice Age, while some of our cousins didn't. Some experts believe that our adaptability, social and communication skills, and the use of tools played a huge role in it. And guess what? Humans didn't just hunker down during that time. We actually moved into new areas. Fossilized footprints found at White Sands National Park in New Mexico prove that humans have been in North America since at least 23,000 years ago. That's close to the peak of the last Ice Age. While a full-blown Ice Age might still be far away, there is a possibility of a mini Ice Age coming our way. Some scientists believe that in about 10 years, we might experience a significant drop in solar activity, leading to colder temperatures in the northern hemisphere. This could result in conditions similar to the Little Ice Age in the late 17th century, when the Thames River in the UK froze over. While scientists aren't quite sure what caused that cooling, it's fascinating to think about the potential changes. We've done it before, so we know that humans will most likely survive the next real ice age, even if we don't manage to figure out a way to stop the next freezing era. But it would come at a high cost. All the ice that would cover most of the northern hemisphere would have to come from oceans, which would cause the sea level to drop. This could mean more land for some countries, but it would also create other problems. Sea levels going down might seem like a great thing at first, but actually, it could lead to some challenges. Having been covered with salt water for thousands of years, the new land might not be very fertile. This means it wouldn't be great for growing crops, and we'd have to find other ways to feed ourselves. Back when humans first started out, there weren't many of us, and there was plenty of food. Now, with over 7 billion people on the planet, it's a different story. We'll need to be resourceful to make sure everyone has enough food to eat.
Ice piracy is like Pirates of the Caribbean, but you gotta swap those tropical seas for icy, freezing waters. And the captain here isn't Jack Sparrow, but a massive glacier in Antarctica. Meet the Polar Ice Glacier. Its calm, sparkling surface might look innocent, but don't be mistaken, it is a pirate, and a pretty skilled one too. Instead of gold, it's been stealing ice from its neighbors at record speed, and scientists can't believe what they're seeing. So, what exactly is ice piracy? Arr! This is a strange kind of glacier movement, where one glacier starts taking ice from another nearby. Instead of minding its own business and slowly sliding toward the sea, it suddenly changes course and begins pulling ice that used to belong to its neighbor. The pirate glacier speeds up, the victim slows down. The problem is that the balance of ice in the region might get completely thrown off. This isn't brand new information though. Scientists have known about this quirky behavior for quite a while. But they used to think that this process took hundreds, maybe even thousands of years. Now, something really strange is happening in Antarctica. We're seeing, for the first time ever, a glacier pirate in action, and it's moving much faster than anyone expected. It all started when researchers from the University of Leeds began looking at satellite images taken between 2005 and 2022. They wanted to analyze the rates of flow from 8 ice streams in West Antarctica. And yes, glaciers do move. Think of them as huge piles of snow that have turned into solid ice over time. This ice slowly changes shape, shifts, and moves. That's why glaciers are often called rivers of ice, because they flow, for real. Gravity is what makes it happen. The ice slowly slides and deforms under its own weight, thanks to the pull of gravity. And when it comes to glacial movements, they can either advance or retreat. If more snow and ice build up and melt away, break off, or evaporate, a glacier will advance. But if it loses more than it gains, it will retreat. Oh, and glaciers also move at different speeds, depending on things like the slope of the land beneath them. But if that flow starts speeding up, well, that's bad news for coastal communities all over the world, because that means more ice is moving from land into the ocean, which contributes to Antarctic ice loss and, eventually, sea level rise. Now, back to the recent ice research in Antarctica. The team calculated ice velocity using a tracking technique that measures how visible features like cracks or rifts on the ice surface shift over time. And they found that 7 of those 8 Antarctic glaciers had sped up. On average, they've doubled their speed since 2005. Given the impacts of how Antarctica's climate is changing, warming up more and more each year, this doesn't really come as a surprise. But here's something strange. One glacier, just one, slowed down. We're talking about the Polar West Glacier. It slowed by about 10% over the study period. But how can a massive chunk of ice just hit the brakes, so to speak? To figure that out, researchers looked at its surroundings, and there it was, the culprit, the Polar East Glacier. Experts think Polar West slowed down because it's flowing toward its pirate neighbor, Captain Polar East. That one's moving much faster. In fact, it's one of the fastest glaciers in the area. Its speed has been increasing by about 105 feet every year over the study period. Okay, that might sound slow, even for a tortoise. But for a glacier, that's disturbingly fast. Polar east is the Usain Bolt of ice chunks, and that's not even the most impressive part. The strange thing is that it changed its flow direction. Instead of moving straight ahead like it used to, it's now turning towards its neighbor, polar west, and pulling ice from it. Scientists think this is happening because the ice at the point where the glacier meets the ocean is melting faster than before. That glacier melting makes the ice thinner, and as it thins, it changes the way the ice upstream flows. So now, instead of feeding both glaciers evenly, more of that ice is being funneled onto polar east. In short, polar east is speeding up and changing its course. So now it's pulling or stealing ice from its slower neighbor. And just like that, this mysterious glacier in Antarctica became a real ice pirate. Okay, this whole ice piracy thing isn't that weird. I mean, it's part of how glaciers normally behave. Slow, dramatic, and occasionally a little mischievous. What really blows scientists' minds is how fast it's happening. They used to think this was a super slow process, something that would take hundreds or even thousands of years. But this one is taking place in just 18 years. And this is a huge satellite discovery in Antarctica. I mean, scientists were only able to spot it thanks to the Copernicus Sentinel-1 mission, a pair of European satellites that use radar to keep an eye on Earth's surface. They can track changes in ice, land, and ocean with incredible precision and coverage, making them perfect for studying how the polar regions are changing. Because here's the thing, keeping an eye on the coldest parts of our planet is becoming essential for our future. And this particular part of Antarctica, where both the polar west and east glaciers are located, is thinning faster than anywhere else. Its glaciers are retreating at record speed. The grounding line, the point where the glacier stops resting on land and starts floating on the sea, is moving backward. When that happens, the ice sheet slides into the ocean even faster. But scientists say glaciers aren't just melting, they're reshaping themselves in completely new ways. And that's exactly what's happening with the Polar East Glacier. Seeing a pirate glacier in action firsthand has once again changed how scientists look at things. The new data on ice piracy shows something they've never seen before. Glaciers and floating ice shelves are interacting in new and surprising ways. So, more and more, experts need to rethink how these icy giants behave as the world warms up. And that's a big deal, because they play a significant role in how fast sea levels rise this century. In fact, Antarctica's glaciers are one of the biggest reasons our oceans are swelling. The continent is losing about 135 billion tons of ice every year. That's like dumping tens of billions of Olympic-sized pools of water into the ocean annually. If all of its ice melted, sea levels would rise by about 190 feet. That kind of rise would flood much of Florida and huge areas of the Netherlands and Bangladesh, for example. Many small island nations would completely vanish beneath the waves. Now, you might be asking yourself, what's hiding beneath all of Antarctica's ice? Well, it might look flat from above, but underneath that mile-thick layer of ice lies a whole landscape of steep mountains and deep valleys, crossed by winding rivers. Those hidden rivers could play a crucial role in how the ice sheet reacts to all this unusual warmth. Scientists now predict that as Antarctica's ice sheet keeps melting and thinning over the next few decades, those subglacial rivers will grow, overflow, and shift into new paths. This could make some of the biggest glaciers near the coast start to break apart faster, and that would make sea levels rise more quickly. So that's why understanding these changing dynamics and glacier movement, like our icy pirate, is so important. Every new discovery helps scientists figure out what's really driving Antarctica's glaciers and how they are responding to a warming world. The more we learn about these frozen giants, the better we can predict what might happen next and how changes down in Antarctica could ripple across the entire planet.
Do you know that NASA explores not only stars, planets, galaxies, or black holes? Hard to believe, but yes. The agency also works on discoveries here on our home planet Earth. So what has NASA recently discovered? Is there life under the ice? While they were analyzing data recently, they discovered something unbelievable hiding under Antarctica's ice. And this discovery not only changes everything we know about the whole water system of the Earth, but it may also help with research about life in space. Humankind's existence might depend on understanding Antarctica and its secrets. So, the recent discoveries reveal vital information about our survival. But before we continue, let's see how much you know about this place, where it's only ice as far as your eyes can see. Antarctica is one of the world's 7 continents in the southern hemisphere. It's the 5th largest continent in terms of total area, and that means it's almost twice the size of Australia. Want to see real meteorites? Go to Antarctica. Due to its dry climate, Antarctica is one of the best places to observe space. But what's even greater is that you can find meteorites on the white surface of the continent. Scientists have already plucked about 45,000 meteorites from the ice, and they think they can see another 300,000. Since there aren't many terrestrial rocks there, it's easy for them to spot them, thanks to their dark color. Antarctica's dry desert environment also helps preserve them, even the ones that fell to Earth more than 1 million years ago. And can you imagine any volcanic activity in Antarctica? It's hard. But this place is where fire meets the ice. West Antarctica is where most volcanic activity occurs. Scientists recently found that 138 volcanoes exist in West Antarctica alone. Wow! You would think that Antarctica is always cold, but no. Its coastal regions can get as warm as 50 degrees Fahrenheit. But have you ever wondered what Antarctica would look like if there were no ice? It may seem unimaginable now, but it was not always covered by ice. That was 34 million years ago, though, so nobody could tell how the continent's surface would be without the ice. But NASA changed that. They generated computer simulations and created the most accurate map of it as of today. What they saw was incredible. The continent was not flat at all, like it seemed. It's pretty bumpy, with valleys, rolling plains, and high mountains. But this was nothing next to what they had discovered under Antarctica's ice. So, what is it? Drum roll, please. NASA found 2 new subglacial lakes. And what's even cooler about it is that they spotted these lakes from space. How is that? If your answer is high-tech satellites, then you're right. In 2003, NASA launched a satellite called IceSat. It measured ice sheet mass balance and cloud and aerosol heights. The satellite also helped create the ice-free map of Antarctica. In 2010, the European Space Agency launched the second satellite, CryoSat-2. It was for tracking the changes in the thickness of the ice. Then, in 2018, NASA launched the third one, IceSat-2, a follow-on to the IceSat spacecraft. It measured ice sheet elevation and sea ice thickness. It was NASA's most advanced Earth-observing laser instrument. It delivered the highest precision data. And when that was combined with the data from the other satellites, it was possible to spot these 2 new lakes near a pair of larger ones. But how is it possible that these lakes exist in the first place? The average thickness of most Antarctica ice is approximately 1.2 miles. However, it can get over 1.8 miles thick in some places, especially during the winter. So, you might think that there's nothing under there, but science says otherwise. It's not quite possible to see it with your bare eyes, but the continent's ice is slowly but constantly flowing in different directions under the force of its weight. But scientists could not figure out how water moved for many years. That started to change in 2007, when data gathered from the IceSat provided insight into what hides beneath the surface. They first discovered an entire network of meltwater lakes connected under Antarctica's fast-flowing ice streams, and there were hundreds of them. Scripps Institution of Oceanography glaciologist Helen Amanda Fricker figured that the elevation changes measured by IceSat happened because of the dynamics of these lakes. They did not hold meltwater statically. Instead, they were filling and draining continuously over time through a system of waterways. And as they did that, the ice above rose and fell. But where do they drain? The ocean, of course, and it drains a lot. A recent study, co-authored by Fricker, found that the drainage of one lake flushed as much as 198 billion gallons into the ocean in only 3 days. Countless mysteries about how nature works are still waiting to be solved. But finding the 2 new lakes will give scientists a better picture of how fast the Antarctic ice sheet will change as the climate gets warmer, and how this will affect global ocean currents and sea level rise. The filling and draining cycle of the lakes also caused the ice sheet to suffer cracks and crevices. So, the information they find from these new lakes will also give them a better understanding of the damage on the surface of the ice. They will also be able to assess how this filling and draining system influences the speed at which ice slips into the oceans and seas. And that means they can evaluate how the added fresh water may alter marine ecosystems. This discovery may also suggest whether life is under the ice. Wow! Scientists drilled through about 3,504 feet of ice and found that water samples taken from one of the lakes contained approximately 10,000 bacterial cells per milliliter. Such a high number of bacterial life is a good sign, because that means the icy waters might also support higher life forms, such as microanimals, and one of these new lakes might even be their home. But the most exciting thing is that the new lakes might help them understand whether life on other planets is possible. Scientists believe any life below the frozen surface of the planet Mars might follow the patterns seen in Antarctica's lakes. So, there is a possibility that they might find critical new information on the type of life that may have existed on the red planet. You wouldn't want to be there during the winter, though. The lowest temperature on Earth you can experience is negative 128 degrees Fahrenheit. In 2010, there was an even lower temperature of negative 135 degrees Fahrenheit. And you may feel this cold much worse due to the strong and dry winds. Did you know that the size of the ice surface on Antarctica also changes throughout the year? It's about 1.2 million square miles during the summer, but when it's winter, it grows to 7.3 million square miles. Yet, despite the change, it remains the largest piece of ice on Earth. Sorry, Arctic, you lose. Do you know these cute little penguins? Consider these animals the locals, because there is no native population in Antarctica. It's a no man's land, because no single country owns it. But do you know who really owns it? 5 different species of penguins, seals, and killer whales. Ha. Despite the continent's harsh conditions, you can visit it as a tourist for fishing and research purposes. Around 5,000 people reside on the continent during summer at research stations. But when winter comes, the number naturally drops down to 1,000. Antarctica's ice blanket makes up 70% of the world's freshwater reserves. Imagine what would happen if it melted. The global sea levels would be raised by almost 200 feet. A colossal iceberg, more giant than a city, broke away from Antarctica in mid-2021. It's so big that it's 40 times bigger than Paris and 73 times the size of Manhattan. Imagine that you come out of your small holiday shack on the coast of South Africa, near the town of Port Elizabeth. You have a cup of tea in your hand as you've just woken up. You stand near the edge of your lookout, the vast Indian Ocean before you. Something catches your eye. To the right, there is something so monumental, you can't comprehend it. It's a giant slab of ice, 300 feet high, and stretching away many miles, as far as the eye can see. It rolls slowly, but relentlessly on, heading out into the deep sea. If it goes far enough, it could reach the western coast of Australia. Playing in front of it are a pod of dolphins, like they sometimes do off the bow of a ship. Yet they're just specks compared to the mammoth size. You're so shocked that you drop your cup. Your eyes are as big as saucers. It's like something out of a science fiction movie. Are you dreaming? Are you seeing things? Nope. It's A76. It's real, and it's currently on the move. What could happen to it is anyone's guess. Well, scientists have a few theories, But let's get a grasp of its size first. The iceberg is 110 miles long and 16 miles wide. It's basically the shape of a gigantic finger. If you were standing at the coast of Dover, looking across the English Channel toward France, the iceberg would be almost as wide. The channel is 21 miles across at its narrowest. That means approximately 2/3 of that distance would be filled with the iceberg. That's if it were drifting finger pointing down, so to speak. If it were facing the other way, it could still enter the English Channel, but as it got closer to the narrowest points, it would smash into the coasts of both England and France. It would go up over land. It would slide over the green fields of England, the white ice bold against the rich green. It would cruise past the vineyards of France. It was temporarily lowering the temperature of everything around it. Those grapes would be like jelly crystals. It would skim right over highways, cars stopping to observe this colossal thing like a visitor from another galaxy. You could pluck chunks off it for your drink as it sailed past. Failing that, you could scale it and go ice climbing, right on the outskirts of London. It would certainly be handy in the summer. But let's get back to what actually happened, and what scientists think will happen to it. As of the beginning of 2022, A76 is the world's most giant floating iceberg. It was calved from the Filchner Ronne ice shelf in Antarctica in the middle of May 2021. Ice calving, also known as glacier calving, is the breaking up of ice chunks from the edge of a glacier. It then pulls away from the ice mass into a separate entity. If you were nearby, you would hear a lot of cracking and a massive booming sound. Blocks of ice up to 200 feet would break free and crash into the water. It would cause huge waves. Not even adventurous surfers would want to tackle those breakers. Ice calving is a natural event. The area where A76 broke off has seen little change in recent decades. There have been even larger chunks of ice than A76, but this one is currently the largest in the world. Scientists at the British Antarctic Survey spotted it. There are satellite images of it breaking free, as captured by the European Space Agency's Sentinel-1A satellite. The size at the calving was an estimated 1,670 square miles. Right now, it's in the Weddell Sea around Antarctica. The Weddell Sea is part of the Southern Ocean. It was named after the Scottish sailor James Weddell, who entered the area in 1823. Scientists have deemed the Weddell Sea to have the clearest water of any sea. Imagine peering down into its depths from a boat. What a fantastic view it must be. The area is full of whales and seals. As you look down, you may see killer whales, humpback whales, minke whales, leopard seals, and crab-eater seals. And if you look towards land, you'll likely see a colony of Adelie penguins. They're the dominant penguin species in this area because they adapt to the harsh environment. In fact, this is the only location in the world they live. What an incredible array of wildlife to observe, all from the comfort of the ship's deck, while you drink another cup of hot tea. It gets pretty cold in these parts. To get an idea of what could happen to A76, scientists refer to other data, such as the even more enormous iceberg called A68. It was calved from the ice shelf known as Larsen C off Antarctica in 2017. While it may be exciting, though a little daunting, to think of it also sailing up the English Channel, A68 floated out to warmer seas and, by early 2021, had all but dissipated. That was a relatively quick demise. Some icebergs have been observed floating around for up to 18 years. Suppose they remain in the relatively cold waters. It all depends on where A76 decides to go. Satellites have helped scientists keep track of these monstrous movements, whereas they would go unnoticed in the past. That's how they know that by day 148, this iceberg had split into 3 fragments, imaginatively titled A76A, A76B, and A76C. The numbers might be boring, but they're based on the Antarctic quadrant in which they were first sighted. If these enormous chunks do break up entirely, it will not add to rising sea levels because it was already part of the floating ice shelf. Imagine these ice chunks in your glass. They already take up a certain amount of space. They will simply change form into water. Icebergs like this one are different from glaciers or ice sheets found on land. Those are the things that help to raise sea levels when they break off and melt. For example, if the whole of Antarctica's ice sheet were to melt, it could raise sea levels by nearly 190 feet. If you think A76 is enormous, and it clearly is, there was another that makes it look small in comparison. On record, the largest iceberg was sighted in November of 1956, 150 miles west of Scott Island in the South Pacific Ocean. Ironically, it was seen by a ship known as the USS Glacier. It was sized over 12,000 square miles. This iceberg was larger than the country of Belgium. What may happen to the chunks of A76 will depend on a few factors. Ocean currents can make a significant impact, and wind direction and speed can too. They may move closer to coastlines, where they can freeze into pack ice. They can also drift into shallow waters and hit the seabed, called seabed gouging. The deepest part of the iceberg can act like the keel of a boat. It digs into the ocean floor, but the sheer size of the iceberg keeps it moving. Soon it's tearing up the floor, creating a long, narrow furrow or a gouge. Fish would scatter, the earth would shake, the noise would be tremendous. It's actually quite common in offshore environments near where ice is found. You would not want to be scuba diving nearby when one of these rips through. However, it would make for a spectacular sight. Generally, icebergs deteriorate through melting and fracturing, which, as you can imagine, changes the mass and the surface area. Combined with wind and ocean currents, it can make iceberg modeling difficult. As for A76, we'll just have to wait and see. Before we go, let's return to our imaginary voyage down the English Channel. The island of ice, 73 times the size of Manhattan, with its gigantic frosty finger pointed down toward the Celtic Sea, rolling steadily onwards, unable to be stopped. Hundreds of thousands of people have flocked to the coasts of both England and France to watch this extraordinary spectacle as it cruises by. On top of the ice, there are thousands of penguins playing happily. They almost look to be waving back to the abundance of sightseers who cheer them on their way, the children jumping with joy at the most spectacular sight they've ever witnessed. There's not much to do in Antarctica except scientific work. You could check out the wildlife, like some cute penguins and seals, and you'd get to see the occasional whale swimming around. Antarctica is one of the biggest lands out there that's only inhabited by scientists and researchers from all over the world. These scientists dug a hole through some pretty thick ice to study the ancient air and how the atmosphere cleans itself. They used a special drill and dug a clean cylindrical hole 450 feet below the surface. Some of this ice can be up to 800,000 years old and is a good indicator of what the climate was like in the past. It's like checking out tree rings to determine how old a certain tree is, except it's more complicated than that. After the effortless digging, they decided to drop some ice to the bottom of the hole to see what would happen next. They heard some really unusual sounds. It felt like being on a spaceship traveling through a bunch of obstacles with many rocks smashing into each other. The pitches changed over the quick descent of the block of ice, ranging from high pitch and ending with a low heartbeat-like sound. The scientists were puzzled when they first heard this and dropped some more ice, only to find out that the same type of sounds were being produced, just in different variations. They couldn't tell what was down there, and, more importantly, why these kinds of sounds were produced. Antarctica boasts quite a few volcanoes, many of which are under super thick sheets of ice. Scientists discovered 91 volcanoes and claimed there could be more, potentially making it the most extensive volcanic region in the world. While they were doing regular scientific research, they came across many unmistakable large cone-shaped figures underground. Some were as deep as 2 miles in the ice. Some of the peaks were over 3,000 feet tall and dozens of miles across. But on the surface, it's as plain as a sheet of paper. They may have dropped that block of ice inside an actual volcano that they were standing on, but it's unlikely. Even though the underground volcano presence was discovered by accident, there's a small chance they were actually standing on one where they had their workstation set up. It's more likely that they worked in an area where studying ancient climates is easier and less dangerous than other places. They collect ice samples and study them in a lab. It's like discovering a prehistoric insect embedded in amber millions of years ago when dinosaurs used to roam the land. But instead of little bugs, scientists study ancient dust, air bubbles, sea salts, volcanic ash, and anything else that may have come from the environment. They can practically tell how the climate was during that time. These ice samples might show that Antarctica's western ice sheet melted when the Earth's climate warmed up. If it did, then it's likely to happen again. That would mean sea levels rising, affecting coastal cities and small remote islands. But scientists aren't sure it's true, despite some evidence to back it up. The process of studying ice samples can take a week or even a year, depending on what they find. They crush or melt the sample bit by bit. And like those tree rings, the deeper the layer, the further we go back in time. In order to study ancient bubbles trapped in ice, researchers have to crush the samples under a vacuum hood to keep the air out while extracting the air and putting it in vials. There are various instruments and devices to study the ice samples, but because it's so sensitive to damage, each measurement must be in a clean room setting so that nothing gets compromised. The scientists have to wear proper bodysuits and many layers of gloves and constantly get ventilated. Even something as tiny and insignificant as a fingerprint can ruin a sample. They look for certain patterns to see changes in the atmosphere's composition and temperature. But dropping a few blocks of ice down a hole wouldn't be so bad. The reason why it made such a peculiar sound is the same reason why a moving car sounds different when it's honking than when it's stationary. The scientific word for it is the Doppler effect. It's an obvious change in the frequency of a wave with respect to an observer who is moving relative to the wave source. The effect doesn't mean the frequency of the sound changes, it just shifts. And this can be said about other types of waves, like water and light. But sound waves are the most popular ones when it comes to the Doppler effect. So, when the scientists dropped the ice block down the bottom of the hole, the sound waves traveled back up and bounced around the narrow tube where they drilled. That's why they got the pew pew sound. Let's not forget that this ice block traveled 450 feet beneath us. Oil ships dig holes in the oceanic crust that go thousands of feet beneath the Earth. The Kola Super Deep Borehole in Russia is the deepest hole ever made by humans. It goes more than 40,000 feet below the surface and took almost 20 years to reach 7.5 miles. Below it is only half the distance to the mantle. In terms of the whole Earth, this very deep hole is literally scratching the surface. This wasn't a hole to dig for oil, and wasn't in the ocean either. The drilling was stopped in 1992 when the engineers found out that the temperatures were 100 degrees Fahrenheit higher than they predicted. And then it was abandoned, and it's just been a barren hole now. But that's the closest we've dug to the center of the planet. The scary thing is that some of the workers on the site could hear voices coming from within. All the way in Yemen, an ancient hole exists in Barhout, in the east of the country in the middle of the desert. It's actually closer to Oman than to the capital Sana'a. This hole has puzzled experts and locals. Unlike the holes in Russia and Antarctica, this wasn't man-made. Or was it? It's been around for many years, and the locals try to steer away from it. They don't even like talking about it, since they claim it brings bad luck to those around it, or to whoever utters its name. They claim it was created as a prison for spirits, but many rule that out. The hole is 98 feet wide and somewhere between 330 to 650 feet deep. You can also hear strange sounds coming from the inside. But according to some scientists, the well has little to no ventilation and barely has any oxygen down there. So it's unlikely that anyone or anything lives down there. The Challenger Deep in the Mariana Trench caught some low-pitched grumble sounds in March of 2016. Some of these grumbles were followed by screeches. They caught these sounds in a span of weeks, using a titanium-encased microphone so that the immense pressure of the lowest point on Earth wouldn't crush it. They had to lower it slowly as well, since it's 1,000 times the atmospheric pressure at sea level. For 23 whole days, the microphone recorded typical sounds of whales passing by and boats sailing across from above, and even rumbles of nearby earthquakes, but they still couldn't determine what caused those initial sounds. The researchers couldn't understand if the noise from the bottom of the Mariana Trench was caused by humans or was natural. They also wanted to know if these sounds affected marine life, like dolphins and whales that rely on echolocation. They still can't figure it out. But scientists estimate that the ocean is about 10 times noisier than it was 50 years ago. With technological developments in shipping, submarines, and underwater construction, the ocean will only get louder with time. Northern lights come with sounds, which nobody talks about. They're usually audible when the auroras are at their most powerful presence. Scientists were always puzzled as to what caused the faint popping and crackling, even though they were very far above us. They used some special microphones and found out that the sounds came just 230 feet above us, which is pretty low. They're caused by electrical charges gaining power in a specific region of the auroras. The electrical charges are disturbed by magnetic storms that fire up the northern lights. As a result, some tiny sparks are released into the atmosphere, causing the faint crackling and popping noise.
On April 10, 1912, crowds gathered at Southampton Beach to wave off what was, at the time, the world's largest and most prestigious ship, the RMS Titanic. The cost of the most expensive first-class parlor ticket was $4,350. That's around $70,000 in today's money. But barely 5 days after steaming away, the ship was swallowed by the Atlantic Ocean. So let's rewind and go back to what actually happened on that fateful night. The captain wanted to set a speed record for the ship's maiden voyage and arrive early. The ship was deemed unsinkable, so he went full throttle into the dark Arctic waters. After spotting the 100-foot iceberg, the crew desperately tried to steer the vessel away and avoid the collision, but the Titanic was traveling too fast, and the iceberg tore down the side of the ship, creating a huge opening in the hull. It wasn't a continuous rip, and damage was caused in several places. In total, the damage spanned along an area of around 300 feet. But the ship's designers had prepared for the prospect of a collision and added watertight compartments down each side of the ship to act as a buffer zone. 4 of these compartments could be breached, and the ship would still stay afloat. But because the iceberg tore down the side of the Titanic, it ripped holes in 6 compartments. The compartments didn't extend up the total height of all decks and weren't actually sealed at the top. This is why, when more than 4 were flooded, water reached over the top of the bulkheads and filled the remaining compartments, causing the ship to sink into the ocean. Think of it as water spilling over an ice cube tray. But what if the collision was head-on? Would it still have sunk? Ships are designed with potential crashes in mind, and most vessels have collision bulkheads in the bow. Most of all, it's like your car's bumper or crumple zone. It's a safety feature that can withstand a direct hit. The bow could have taken some of the impact, and some experts have suggested that if it hit head-on, only 2 to 4 of the watertight compartments would have been flooded. So, in theory, the Titanic might not have sunk, and it might have even been able to continue sailing to its final destination at a much slower speed. The force of impact would likely have been huge, though. But although passengers would have been injured by the force, they'd have been able to stay on the ship to wait to be rescued by other ships, rather than being forced into the icy waters of the Atlantic. Still, one of the Titanic's designers, Edward Wilding, suggested that the force of the impact might not have actually been that big. He told the British Inquiry that lots of people scarcely felt the collision, and he believed the ship would not have sunk if it did hit the iceberg head-on. The ship was also designed with remotely operated watertight doors between all compartments, so any floods could have been quickly sorted out. Because Titanic had 6 breaches from the side collision, and because it happened so quickly, sealing the doors wouldn't have made a difference, as it was essentially impossible to save it by that point. The ship immediately began to flood, with water pouring in at a rate of roughly 7 tons per second, 15 times faster than it could be pumped out. So, while it sounds like the Titanic would have survived had the ship hit the iceberg head-on, this idea does come with some issues. First off, the collision bulkheads were designed to survive a crash with another ship, not a giant iceberg. If 2 ships collided, both would absorb some of the impact in their bulkheads, sharing the impact and likely staying afloat. But an iceberg is stationary, meaning that Titanic would absorb most of the energy from the collision. If Titanic hit head first, because of the speed it was traveling, the impact would have likely traveled down the whole body of the ship. Just imagine a 46,000-ton ship traveling at around 20 knots. At some point, it hits an iceberg that weighs what could be over 100,000 tons. This collision would likely create a powerful force causing massive damage to the vessel. It is likely that seams would split, staircases would come tumbling down, and rivets would burst open across the ship. All that would have potentially flooded even more compartments. This could have caused Titanic to sink in a matter of minutes rather than hours. But that's just the tip of the iceberg. As we all know, the biggest part of it is hidden underwater. So if Titanic had been traveling head-on, it's likely it would have hit the part of the iceberg below the water first, which would send it veering off course. Hitting an iceberg is not like hitting a brick wall. In this case, the ice under the water would have torn open the bottom of the ship and caused damage to the sides. Icebergs also aren't flat, solid objects. If a flat collision happened, the ship might have stayed afloat, but icebergs come in many shapes and sizes, from domes to wedges. Studies have also been done on the steel used to produce Titanic, and the tests show the metal was about 10 times more brittle than the steel we use today. The ship was built before we understood the effects of low temperature on steel. The old steel used to make the vessel would not bend when faced with freezing temperatures, but break. Recovered pieces of Titanic's hull plates show that the hull just shattered on impact. Hitting head-on would also cause a very severe and abrupt stop, so even if the ship hadn't sunk, there would still have been major issues. Think about when you suddenly hit the brakes on your car, or when the bus stops while you're walking down the aisle and you get flung forward. Passengers would have been thrown across the ship, and because the crash happened at night, most people were sleeping, so wouldn't be able to effectively prepare for any sort of impact. This would result in injuries for most people on board. It would be especially bad for those at the front of the ship, where the accommodation for the off-duty firefighters, greasers, and engineers was. But while passengers and off-duty crew may have been thrown out of bed, there would be a lot more survivors than in the original scenario. Many ships have had head-on collisions and made it back to shore. Not many people know that Titanic actually had two sister ships. The White Star Line, the company that built Titanic, also built vessels called Britannic and Olympic. Captained by Edward J. Smith, who would later helm Titanic, the Olympic set off on its maiden voyage in June 1911. But much like Ford's sister ship, disaster was just around the corner. On its fifth commercial voyage, Olympic collided with a Royal Navy ship, HMS Hawke. While the Olympic received damage to its side, Hawke crashed into the other vessel head-on. The bow of the Hawke was completely crushed by the collision, but because the ship had watertight compartments, it managed to survive the impact and later returned to shore for repair. Another study case is the SS Andrea Doria, which was an Italian ocean liner that made global headlines in 1956. Like the Titanic, the Andrea Doria was heading for New York City on its 101st voyage when disaster struck. On July 25th, the vessel collided with the 524-foot Swedish passenger liner Stockholm. The Stockholm hit the ship head-on, but the point of impact for the Andrea Doria was on its side. The front of the Stockholm was completely smashed, but because the impact was on its hull, it managed to survive. The Andrea Doria, however, sadly sank due to the collision being on the side of the ship. So these cases could suggest that maybe the Titanic would have survived had it hit the iceberg head-on. But we have to remember that the Titanic hit the thing full speed, whereas both the Olympic and the Andrea Doria were traveling slower.